Hello friends, good morning. Welcome to our chemistry class. Today we are going to discuss some of the questions asked in Apset 2020. Okay friends, let us start. First question. The elements A, B, C, D have the following electronic configuration. Means here what they asked means, see, here they have given the electronic configuration. So based on the electronic configuration we have to find the elements which are belonging to the same group. Okay, see, actually here I had taken only three options because here my main aim is just you make this to understand friends, that's it. Okay friends, let us see. Here the atomic number is 5. Okay, 2 plus 2 plus 1, that is 5. Okay, here the electronic configuration is 6 plus 2 8 plus 2 10 12 13. Okay, here the electronic configuration is 6 7 8 9 10 12 15. Okay, so according to our question we had to find the two elements belonging to the same group. Okay, so we know the atomic number 5 is boron. Okay, the atomic number 13 is aluminium. So we know that boron and aluminium belongs to the same group. So our answer is 1 and 2, that is A. Okay, next, second question friends. Okay, see, the molecular orbital electronic configuration for X anion is, means here they have given electronic configuration. Okay, here we had to find the anion X. Okay, okay, let us see the solution for this. Okay, before going to start this we should know one thing. Okay, that is K star, or we can say it as K ash. Okay, means sigma 1s2 and sigma star 1s2. Okay, this thing we had to know. Okay, if we know this then it is very easy for us to solve this. Okay, see, K star means sigma 1s2 and sigma star 1s2. So now let us start counting. Okay, 2 plus 2 4. Okay, that means here K star is completed. Okay, that means 4. Okay, 4. Next, 5 6 8 9 10 11 12 13 14 and 1, that is 15. Okay, so here we have to find in which, okay, in which option we have the 15 electrons. Okay, so if we observe this we can find this as the answer, because nitrogen means see 7 electrons. Okay, here 2 nitrogens are present, that means 14 electrons, and here we have one negative charge, that means 15 electrons. So our option is B friends. Okay, next, third, shape and expected hybridization of BrO3 minus and HOCl. Okay, let us try to draw the structure for this. Okay, BrO3 minus. Okay, we had to draw like this. Okay, we know, okay, bromine is halogen. Okay, so see, if we count the electrons, 1 2, means now I am counting the electrons related to bromine. Okay, so 1 2 3 4 5 6. Okay, that's why here I have kept one lone pair of electrons. That means here we have 1 2 3 3 sigma bonds and one lone pair. So this is a, means it undergoes sp3 hybridization and it will have the pyramidal shape. Okay, next let us see this HOCl. Okay, HOCl, so the structure for this HOCl is, means we can say that it may be a bent or V shape or angular. Okay, here it have two lone pair of electrons and two bond pairs, so that here it will undergoes sp3 hybridization and the shape is bent or V shape or angular. I think in options they have mentioned bent. Okay, next, the fourth question, means here it is based on hard acids and hard bases, soft acids and soft bases. Okay, before going to answer this, let us know these minimum basic things friends. Okay, so try to remember just these points. Okay, see, cations are acids. Okay, cations means atoms or the molecules which are having positive charge. Okay, so those are said to be acids. Okay, so cations or acids. Next, hard acids or Lewis acids, this thing we had to know. Okay, hard acids or Lewis acids. Next, heteroatoms of second row of periodic table. So in the periodic table, okay, we have to observe the second row. Okay, second row, then means the heteroatoms which are present in the second row are said to be hard, like nitrogen, oxygen, fluorine. Okay, try to remember this. Oxygen is always hard. Okay, phosphorus is sometimes soft, sometimes hard, like that. Okay, so just based on these points, just try to answer. Okay, actually these are the four options, okay, given in the paper. Okay, first we know that cations or acids. Okay, first try to observe the options in which the positive charge is present. Okay, in beryllium and platinum they have mentioned the positive charge, that means these two are acids. Okay, these two are acids. Next, see, oxygen is always hard, so here the oxygen is present, so that it is hard. So just based on these clue points we can easily answer this. Okay, okay, just let's see this. So beryllium plus 2 is hard acid. Okay, acid because it contains a positive charge. Okay, next, Pr3, it is soft base. Okay, phosphorus containing this one, so soft base. Next, here the cation is present, that means it is acid, but it is soft acid. Next, R2O, this is hard base, so our option is C, friends. Next question is related to the, means here the order is asked based on p character. Okay, so increasing p character. Okay, they have asked the p character for the interhalogens. Okay, see here, see, they have given these interhalogens. Okay, I think you have idea about the interhalogens, means in between, means here we have two halogens. So interhalogens, see, iodine and fluorine, these two are halogens. We know halogens means fluorine, chlorine, bromine, iodine, like that. Okay, see what they asked about the increasing p character. Okay, if we find the hybridization of if3, we will get sp3d. So for this sp3d2, for this sp3d3. Okay, so see here we have to count the number of orbitals. So here 1 plus 3 plus 1, that is 5 orbitals are present. Okay, here the 6 orbitals are present, and here the 7 orbitals are present. Okay, see here only, means here only the 5 orbitals. So only 5 orbitals are present, means here the p contribution is about 20%. Okay, that, okay, so here the p contribution is 20%, but here 6 orbitals, so 6 orbitals are present, that means p contribution is less than 20. Here the 7 orbitals are present, so here the p contribution is less than this. Okay, here what they asked about the increasing p character. Okay, so here the p character is more for if3, because here only the 5 orbitals are present. Okay, next if5 followed by if7. So our answer is, or our option is C. Okay, next, sixth one, arrangement of chlorine, sulfur, phosphorus and silicon in increasing order of electron affinity. Okay, see, whenever, okay, we hear the word electron affinity, we should know that in the entire periodic table chlorine has the highest electron affinity. That thing we should know. Okay, so in the entire periodic table, the element which is having more electron affinity is fluorine, and more electron affinity is chlorine. Okay, more electron negativity is fluorine. Okay, so electron affinity, they asked electron affinity, and they have mentioned, means here they have given silicon, phosphorus, sulfur and chlorine. Okay, see, means in the periodic table also they are present in this manner only. Okay, silicon, phosphorus, sulfur, chlorine. Okay, see, we know that chlorine have a highest electron affinity than sulfur. Okay, we know these two. Okay, we know that usually in a period electron affinity increases. Okay, this is actually the regular trend. Okay, electron affinity usually increases in a period, but this silicon and phosphorus, so this is actually the exceptional case, friends. Okay, this thing we had to remember. Okay, okay, see here the silicon has more electron affinity when compared to phosphorus. This is mainly due to the extra repulsion. Okay, so extra repulsion leads to lower electron affinity for phosphorus than silicon. Okay, hope you understood this, friends. Next, seventh question, friends. See, the complex which shows spin crossover. Okay, spin crossover, see, means this is we can say that this is the theoretical, means this question is mainly based on the theoretical aspect, friends. because already we know that this, see, iron 110, this fin means this is phenanthroline, okay, phenanthroline taken twice, thiocyanate, okay, this ligand, okay, here this ligand switch its low spin and high spin just by varying the temperature. So just based on the temperature, here the switching of ligand can occur from lower spin and high spin, or so here the switching occurs between lower spin and high spin just based on the temperature. So here the spin crossover is present in this one. So our option is C. Okay, next, which of the following octahedral complexes possess an enantiomerism? Okay, see, these are the four options given by them. Okay, before going to start this, we should know these minimum basic things, friends. That is, metal with a bidentate ligand shows enantiomerism. Okay, friends, this is the most important key point to solve this. Okay, see, the metal which contains the bidentate ligand, okay, we know that in all the four options metal is present. So now we have to observe the bidentate ligand, okay. So we know this is oxalate, this is ethylene diamine, and this is phenanthroline. We know these three are the bidentate ligand, okay. Okay, and so we can say that these three means these three possess an enantiomerism. Okay, these three are bidentate and they shows an enantiomerism. Okay, this thing we have to know, friends, that is trans cannot form means here the trans form cannot show the enantiomeric phenomenon, that we should know. So our means our options are 1, 2 and 3. So the option is A, friends. Next, see, the correct spinal structure of CO3, CO taken 4 times. See, this is the normal spinal, friends. Okay, this is the normal spinal. So the representation for the normal spinal is A plus 2, B plus 3 and O4. Okay, and see, here, see, this A is means this A must be in plus 2 oxidation state and B must be in plus 3 oxidation state. Okay, see, here means normal spinal means, okay, plus 2 occupies the holes of tetrahedral, okay, plus 3 occupies the holes on octahedral. Okay, so here if we observe the option C, this means we have to consider this as A. Okay, A should be in plus 2 oxidation state, so here the A is in plus 2 oxidation state, B should be in plus 3, so this is means we have to consider this as B. B is in plus 3 and this O4. So here the O4 is present. So this is the correct spinal structure of CO3, CO4. So our option is A. Okay. Next, complexes in increasing order of lability. Okay. Lability means, sorry, see, here they have asked about the increasing order of lability. Okay, lability means just easiness of bond making and bond breaking. We can say that ease of reactivity can also be said as lability. Okay, so before gonna start or before gonna solve this, we should know two basic points, friends. That is, transition metal complexes have more inertness when compared to non-transition metal complexes. Okay, see, this one is silicon, this is vanadium, phosphorus, and this is stibbium. Okay, see, so this is scandium, titanium, vanadium. So this is transition metal complex. So we know that transition metal complexes are more inert. More inert means what? They are least labile. So vanadium is least labile. So that means here we should get the means here we get the vanadium at the last. Next, see, cationic charge or the size is inversely proportional to lability. Okay, means if the charge is more means then lability is less. Okay, now we have to observe the charge. Okay, in silicon means here the silicon have a plus 4 oxidation means plus 4 charge, we can say like that also. Okay, next we know that this means already we have observed this vanadium have the least lability. So now we have to observe these two. Okay, here the phosphorus will have the plus 5 charge and here the antimony or the stibbium will be having the plus 2. So as the charge is more, lability is less. That means if the charge is less, then the lability will be more. So stibbium, next we will get the silicon, next phosphorus, and finally the vanadium. Okay, hope you understood this, friends. Okay, next, Okay, see, lanthanoids, we know that means these lanthanoids mostly shows the metallothermic reactions. Okay, promethium 147, it is used in atomic battery, not only used in atomic battery, friends, but also sometimes it is also used in luminescent lamps, paints, like that. Okay, next, this cesium sulfide is used in making crucibles or the dishes. Okay, next, cerium tungsten, luminescent lamps, paints, like that. So mostly the answer may be the C, friends, but here these means these are not, means this is not, we cannot say that this promethium 147 is used only for making atomic batteries, because these can also be used in luminescent lamps, paints, like that. So just try to know the, means just try to know the basic points or the points which are mostly used. Okay, hope you understood this. Next, see, oxidation state of cobalt. Okay, here they asked about the oxidation state of cobalt. Okay, see, this is NCS. Okay, NCS, so it will have the -1. We know that ammonia is a neutral ligand and SO3 will have the -2. So here the -1 and -2, that means here the cobalt will be having +3. Next, here we know carbonyl is neutral. Okay, okay, see, carbonyl is neutral, so it doesn't have any charge. Na exists in +1, so here the cobalt will have the -1, so -1 charge in this. Next, in this S2O3 will be having the -2 charge. Okay, sodium will exist in +1, so okay, that means in sphere -4 oxidation state will be present. Okay, see, so here the cobalt will exist in +3. Okay, +3. Next, metal, this is cobalt, this is carbonyl, so metal carbonyls, so they exist in 0 oxidation state, so our answer is B, friends. Next, see, this is actually the theoretical question, friends. In previous year paper also so many times this question has been asked, friends, so just try to look at this. Okay, consider the following statements at room temperature. So just these are the two options which are correct, friends. See, proton NMR has singlets as, okay, so proton NMR has singlets as 5.48 and 3.18, because at room temperature the 5 hydrogens, 1 2 3 4 5, so the 5 hydrogens on the ligand can rotate freely. So at room temperature the 5 hydrogens which are present on the ligand can rotate freely. Okay, next, IR has carbonyl stretching bands at 1950 and 1860 centimeter inwards. So these two are correct, friends. Next, pair of lanthanoids with highest third ionization energy. What is ionization energy? And ionization energy means the energy required to remove an electron. Okay, the energy required to remove an electron from the outermost orbit. We know that half-filled and fully filled orbitals are highly stable, so it is somewhat difficult to remove the electrons from them. We can also say that for the orbitals which are half filled and fully filled, the ionization energy requirement is very high. These points we should remember, friends. Okay, see, here europium and ytterbium. Okay, the electronic configuration for the europium is 5f7 and 6s2. Okay, for the ytterbium is 5f14 and 6s2. We know that this is half filled and this is fully filled, so it is very difficult to remove the electron because as they are half filled and fully filled, so the third ionization energy is very high for this europium and ytterbium. So our option is B, friends. Next, okay, in the hydroformylation reaction the intermediate, see, simple thing, friends, see, okay, here they have given this, whenever it undergoes the hydroformylation we will get the acylated product. Okay, CO or COCl, like this. So acylated products, it forms a acylated product by migration, so our option is acylated product by migration. Next, here they have asked about the total electron count, friends. Okay, see, we know that osmium have 8 valency electrons, so here they have given 10. We have discussed we have discussed this so many times, friends. Okay, 10 into 8 plus 4 plus 24 into 2, 48, and here they have given the -2 charge, that means +2, so 134. Here osmium, we know the valency electrons present in the osmium are 8, so 8 into 4 plus the valency electrons present in nitrogen are 5 plus carbonyl means 2, so 12 into 2, 24, and here one negative charge is present. That means here we had to add one electron. Okay, next hydrogen means 1, so here the 2 hydrogens are present, so 2 plus 6 into 8 plus 8 into 6, that means 86. Next osmium means 8, so 8 into 7 plus 21 into 2, so 98. Okay, this is the most easiest question, I think. Next one, see, okay, sorry, yeah, see, this is the means this is the general theoretical question, friends. Okay, in the cytochrome C, iron is present. Okay, in the chlorophyll, magnesium is present, so magnesium is present in chlorophyll. Zinc is present in alcohol dehydrogenase. Okay, clamodalin contains the calcium, so option D, friends. Next means we know that mostly, okay, potassium, rubidium and cesium, lithium, sodium, potassium. Okay, first group elements means we know lithium, sodium, potassium, rubidium and cesium. So the 3 elements like potassium, rubidium, cesium, these 3 elements are usually used as ionization suppressor. So in our options they have given cesium, so our option is A, that is cesium, friends. Next, this is the general question, friends. Okay, SF4 means seesaw geometry it will have, and in this 2 triplets are present. Okay, HPF2 means pyramidal, doublet of doublet. Okay, IF5 means square pyramidal, doublet of quintet. Okay, quintet means what, 4, I think. Yes. Next, PF3 means pyramidal, so quartet. So sorry, quartet means 4, friends. Okay, next, see, Mossbar isomeric shift values. Okay, here the tin or the stannum is common for all these friends. Now we had to observe the halogens. These are tetrahalogens. Okay, here Mossbar isomeric shift values increases. Okay, increases down the group. So fluorine, okay, fluorine, chlorine, bromine, iodine. So our option is D. Okay, next, identify the wrong statement. See, mass spectrometry product direct structural data. Okay, I think I have a little bit doubt about this, friends. Let's discuss about this later, friends. Okay, next, ozone toxicity. So methylene is responsible for the ozone toxicity. Next, 12 principles of green chemistry. Okay, in the green chemistry 12 principles are present. Okay, we had means we should try to remember those 12 principles, friends. Here what they asked means which is not the principle of green chemistry, like that they asked, friends. So using high temperature we can speed up the reaction. So this is not the correct statement, friends, because this is not the principle which is mentioned in the principles of green chemistry, friends. Next, chloramphenicol used usually for the treatment of typhoid, friends. Okay, okay, to treat the malaria. Okay, means usually one question is asked, friends, that is to treat the malaria one drug is extracted from the tree named Cinchona officinalis. Okay, here they have mentioned the chloramphenicol. Okay, chloramphenicol is used for the treatment of typhoid. Okay, next, a shift of lambda max towards the longer wavelength in a molecule is known as bathochromic shift, friends. Okay, see, towards the longer wavelength is bathochromic shift. We can also say it as what, red shift. Okay, red shift or the bathochromic shift. Okay, towards the short wavelength means what, hypsochromic shift or the blue shift. Okay, hope you understood this, friends. Okay, friends, thank you.